A word so short you could whisper it, and yet it holds more distance than the mind knows how to carry. Step outside on any clear night, and the sky looks close. A dark ceiling scattered with pinpricks, near enough to touch if the ladder were only tall enough. Astronomers reach for a tidy little phrase to describe how far those points of light really sit. A light year. It sounds almost cozy, the way it's spoken, as if it belonged in the same breath as a mile, or a mountain, or a walk to the store. It even carries the word "your" inside it, which quietly misleads. A light year is not a stretch of time at all, but a distance. The distance light itself travels, unhurried by nothing, across an entire year. Say it once and it seems small. Say what it actually contains, and it stops sounding small at all. Tonight, we open that word like a door and walk through to find out exactly how far it really goes. A trillion miles. It does not sound like much until you try to hold it. 6 trillion actually, nearly 6 trillion miles in a single light year, 9.5 trillion kilometers if you prefer the metric version of the same impossibility. Put it another way, and it may land harder. The distance from here to the Sun, that warm 93 million mile gap we casually call close, would have to repeat itself more than 63,000 times over before it added up to 1 light year. 63,000 of those gaps laid end to end just to make a single unit of measurement. And here is the part that tends to surprise people. That number is not an estimate. It never rounds. For most of the last century, the speed of light was something scientists carefully measured, refined, argued over, a moving target creeping toward precision. But in 1983, in a quiet room, by international agreement, that changed. Scientists stopped measuring the speed of light and instead declared it, fixed it, at exactly 299,792,458 meters per second. Not approximately. Exactly. The meter itself was redefined around that number, rather than the other way around, which means a light year is no longer a fuzzy, hard-won figure with error bars attached to it. It is exact. 9,460,730,000,000 kilometers, and a bit more if you carry it out to the decimal. A number this precise, describing a distance this vast. There is something quietly beautiful in that combination. Astronomers, for their own convenience, often reach instead for a cousin unit called the parsec, about 3¼ light years, defined by a small angle and a bit of geometry. But for the rest of us, the light year remains the better story, because it never lets you forget what it is actually built from. Not miles, not kilometers, but light itself, and the year it spends traveling. A year of light, stretched taut across the dark. And so it rests. A shaft of sunlight falling across a windowsill left the sun 8 minutes ago. It crosses the roughly 150 million kilometers between the sun's surface and Earth in about 8 minutes and 20 seconds, moving at the very speed that defines the light year itself. It is the shortest true cosmic journey there is, over almost before it begins. Blink twice, and by the time your eyes open again, that light has already crossed nearly the entire span between the sun and us. But that 8-minute sprint turns out to be only the final leg. Before this light ever reached the sun's surface to make that dash, it had already been traveling for a very long time, through a darkness far stranger than open space. Down in the sun's core, fusion produces the photons that will one day become sunlight. But the sun's interior is not empty, and it is not simple. It is a dense, churning crush of plasma, and a photon born there cannot fly outward in a straight line. It is absorbed, and released again. Deflected, absorbed again, bounced sideways, backward, in every direction, through matter far too crowded to let it simply pass through. That flicker of energy may wander this way for 10,000 years, or, by some estimates, for as long as 170,000 years, trapped, stalling, drifting through the sun's own body, long before it ever breaks free at the surface and is finally allowed to travel in a straight line at all. Only then does the 8-minute dash begin. Only then is that light finally free to run in one straight, unbroken line. It is one of the stranger truths hiding inside that tidy word, light year, that the very same beam can be almost eternal and almost instant, depending on which part of its journey you happen to be watching. So the warmth crossing your skin this afternoon carries two histories folded into one beam of light. An outward crawl that may have taken longer than human civilization has existed, followed by a final sprint shorter than making a cup of tea. Patience, and then speed. Sunlight from the sun's surface takes 8 minutes to reach a cheek turned toward a window. And yet, nothing humanity has ever built has crossed even one day of that same light's journey. Voyager 1 left Earth in 1977. It has been flying without pause for nearly 50 years, arcing past Jupiter and Saturn, then out through the frozen dark beyond Neptune, faster than almost anything else humans have ever launched. It moves at about 17 kilometers every second, quick enough to circle the entire Earth in under 40 minutes. And still, after half a century of flight, it has only just now drawn close to a distance of one light day from home. A light year is 365 times farther than that. At its current pace, crossing a single light year would take Voyager roughly 17,000 years, and it isn't even aimed at another star. In about 40,000 years, it will drift within a light year and a half of a dim, unremarkable star called Gliese 445, and that faint, glancing pass is as close as this long journey will ever bring it to anywhere at all. Even our faster machines don't change the arithmetic much. NASA's Parker Solar Probe is the fastest object human hands have ever built, diving so close to the Sun that at its quickest it reaches about 430,000 miles an hour. That's more than 10 times as fast as Voyager, and still only 0.06% of the speed of light. Point that same probe, at that same blistering speed, toward Proxima Centauri, our nearest stellar neighbor, and the trip would take about 6,600 years. Longer than the span from the first pyramids to tonight. This is the quiet joke hiding inside the light year. It isn't a unit built to describe our best engineering, it's a unit built to describe light. And light leaves everything we have ever launched hopelessly, almost comically, behind. A radio signal, moving at that same impossible speed, still needs between 3 and 22 minutes just to cross the gap to Mars, which is why the rovers there can't be driven in real time. Every command is written in advance, sent, and trusted to arrive. Multiply that delay by the distance to another star, and the gap stops sounding like an engineering problem and starts sounding like something closer to geology. Slow, vast, indifferent to how fast we think we're going. Our fastest machines are almost standing still. The nearest star system to our own Sun is not really one star, but 3, and the faintest of them, a small, cool red dwarf named Proxima Centauri, happens to be the closest of all, sitting some 4¼ light years from where you are right now. Close enough in cosmic terms to feel almost like a neighbor. A little farther out, at 4 37/100 light years, its two brighter companions Alpha Centauri A and B, orbit each other slowly, bound to Proxima by a gap of their own, one so wide it would take over 13,000 times the distance from Earth to the Sun just across the space between them. 4 light-years sounds almost close, next to everything else the sky holds. It is not. It is a gap that has occupied serious, funded, mathematically rigorous minds for half a century, and it has beaten every one of them so far. In the 1970s, a group of British engineers took that gap seriously enough to design for it anyway. Project Daedalus imagined a fusion-powered probe, its fuel tanks the size of buildings, built to cruise at roughly 12% of the speed of light, fast enough on paper to reach Barnard's star, 5.9 light-years away, in about 50 years. It was never built. It was never really meant to be. It was a feasibility study, a way of asking, on paper, how close human engineering could come to the problem before the numbers quietly gave out. Decades later, another attempt tried a different shape entirely. Breakthrough Starshot proposed no rocket at all, but thousands of postage-stamped sails, each no heavier than a paperclip, pushed by a ground-based array of lasers to 15 or 20% of light speed, fast enough in theory to pass through the Proxima Centauri system in 20 to 30 years, rather than millennia. For a while it looked almost plausible, funded, staffed, taken seriously by people who build spacecraft for a living. Then, quietly, sometime in the mid-2020s, the project went dormant. Not cancelled with any announcement, just allowed to go still. Neither design failed for lack of imagination. Both understood the physics, respected the numbers, and still came up short against a distance that doesn't care how clever the engineering is or how badly we want it to be smaller. 4 light-years away, a small star waits, patient as ever. The width of a single human hair, seen from 50 meters away across a gap of more than 10 light-years. That was the shift Friedrich Bessel had to catch. For 3 centuries, astronomers had tried and failed to measure the distance to any star beyond the Sun. The method seemed simple enough on paper. Watch a nearby star as Earth swings from one side of its orbit to the other, 6 months apart, and see how it appears to nudge against the far more distant stars behind it. Triangulate that tiny angle, and the distance falls out. But even using the full width of Earth's orbit as a baseline, the shift was too small, too faint, for any telescope, any pair of patient eyes, to hold steady enough to see. Bessel had one of the finest instruments in the world, a Fraunhofer heliometer, built precisely for impossibly small angles. But above all, he had patience. Working through 1837 and into 1838 at the Königsberg Observatory, he trained his telescope night after night on a dim, unremarkable star called 61 Cygni, chosen not for its brightness, but because it crept across the sky faster than its neighbors, a hint that it might be close. He measured and measured again, and let the seasons turn until the pattern held steady. The shift was there. Barely 3/10 of 1 arc-second, and it was real. Bessel's answer, a distance of about 10.5 light-years. Modern instruments have since refined that to roughly 11.5. Close enough, after all that waiting, to call it right. For the first time, someone had reached across the dark between stars and come back with a number. What Bessel proved wasn't only a distance. It was that the method itself worked, that quiet, obsessive watching could turn an invisible wobble into a ruler for the galaxy. That ruler simply needed sharper eyes than his. Those eyes arrived over a century later. Europe's Hipparcos satellite spent the early 1990s doing nothing but stare and measure, gathering star positions precise to 1,000th of an arcsecond, and mapping trustworthy distances out to a few hundred light years. Then came Gaia, launched in 2013, sharpening that precision another hundredfold, down to millionths of an arcsecond, and charting over 1 billion stars in 3 dimensions, some as far as 30,000 light-years from home. Different centuries, different instruments, the same quiet idea underneath. Watch closely enough, for long enough, and even Starlight will hold still long enough to be measured. Watching the sky tonight, you are not looking at one moment. You are looking at many, stacked quietly on top of each other, arriving all at once. Take Polaris, steady above the northern horizon. Its light is about 446 years old. It left that star around the time Shakespeare was alive, and has been crossing empty space ever since, only now reaching your eye. Now look towards Cygnus and find Deneb. Its light has been travelling far longer, over 2,600 years, setting out before classical Greece had risen. And still tonight, it lands in the same glance as Polaris, the same instant, side by side, as if no time separated them at all. Push further, past every star the naked eye can name, to the faint smudge of the Andromeda galaxy. That soft patch of light left its source 2.5 million years ago, long before anything recognizably human walked the Earth. It has been crossing the dark this entire time, for longer than our species has existed, just to reach you on an ordinary night. None of these lights are showing you the present. Polaris as it is now, Deneb as it is now, those are unknowable from here. You are seeing centuries, then millennia, then millions of years, folded into a single look upward. And this is worth sitting with for a moment. Most of the stars you can see with your own eyes are close enough, cosmically speaking, that they are almost certainly still there, still burning, whatever their light told you moments ago. The old worry that you might be staring at ghosts is, for nearly everything in view tonight, simply not true. It is really only the rare, extremely distant object where that uncertainty creeps in at all. So the night sky isn't a single photograph. It's a kind of archive. Different pages open at once, each star its own page, its own year, its own age of light, all laid flat across the same dark ceiling. A record of the past, read all at once, in the present tense. 93 billion light-years wide and only 13.8 billion years old. By every normal rule of arithmetic, that should be impossible. If light is the fastest thing there is, then in the entire history of the cosmos, it should never have been able to travel more than about 13.8 billion light-years in any one direction. Call it 27 billion, edge to edge. And yet the whole visible universe measures more than 3 times that distance. Nothing broke the speed limit to make this happen. No photon cheated. No signal outran itself. The resolution is quieter than that, and stranger. While the light was traveling, the space it was traveling through kept stretching. Picture a photon setting out from one of the very first galaxies ever to form, barely 280 million years after the Big Bang, a galaxy so young, so far, that its light has been in flight for about 13.5 billion years just to reach us now, arriving from a smudge of newborn stars only a few hundred light-years across. Through all of that journey, the universe never stopped expanding beneath it, not the photon moving faster, but the distance between here and there quietly growing, for 13 billion years running. By the time that ancient light finally lands on a telescope tonight, the galaxy that sent it is no longer 13.5 billion light-years away. It's tens of billions of light-years farther than that, carried outward by the stretching of space itself, while its old light simply kept coming. That same stretching does something else, almost as a courtesy. It reddens the light along the way, shifting it toward longer wavelengths, a fingerprint astronomers first read in the 1920s as proof the universe was expanding at all. So the number stops looking like a paradox once you see it whole. 13.8 billion years is how long the light has been falling toward us. 93 billion light-years is simply how far the universe grew in the meantime. The light kept its steady pace. Space did the rest. The farthest galaxy we have ever found is a faint smear 13.5 billion years old, younger and smaller than our own, and still, its light and ours are made of the same thing. Step back from that. Step back from Andromeda, from Deneb, from Polaris, from Proxima Centauri, tucked just over 4 light-years away, and come home to this one sky, the one over your own roof, quiet and familiar. And you are made from that same story. The oldest atoms in you, the hydrogen, were born in the Big Bang itself, older than every star in the sky. The rest, the calcium in bone, the iron in blood, the oxygen in breath, were forged inside earlier generations of stars, furnaces that finished burning before the Earth was even a thought. So the distance was never really the separating thing. 93 billion light-years of universe, and not 1 inch of it is foreign material. It's all the same handful of elements, arranged into stars here, into galaxies there, into a person, lying still, looking up. That is not a small coincidence. It is closer to the whole point. You don't have to cross the gap to belong to it. You already do, and always have. The night sky isn't a distance to be crossed. It's a family portrait. Close your eyes now. The light still arrives, whether you watch or not. This has been a story of the cosmos. Out there, the stories go on, slowly, quietly, as they always have. Let this one drift on without you, until the next journey.